Let's take a look at systems of linear equations in two variables. Guess I should have my calculator up and running. Okay. Our first problem. We've got y is equal to negative 3x plus 2. And y is equal to 4x minus 5. And it says solve the system of equations by graphing. I'm going to do this on the calculator, but what we're going to do is graph each one of these, and where they intersect is your answer. When we say solve the system of equations, it means find out what x and y values cause this to be true. And graphically, that's where they intersect. So let's plug this in. So press y equals, press clear. Put a negative 3x plus 2. Down arrow to y2, and I'll press clear to clear what was not line. We want to put 4x minus 5. Now if I press graph, you look to see where they intersect, and it looks like 1, negative 1. So our answer here would be 1, negative 1. Now we can verify that. This is in point form. This is our x, this is our y. So if I put negative 1 in for the y and I put 1 in for the x and see if this works. And it does. So it's kind of a little bit bad because, is this really 1, negative 1, 1.9, or negative 0.9? You really can't tell. Now the calculator does have a function for finding the intersection of these. If I did second trace, and I chose intersect, it'll come up and ask us for first curve, and I press enter on that. Come up and ask us for second curve, and I'll press enter on that. It'll come up and ask us for the guess. Now if you're dealing with lines, like we are here, all you have to do is just press enter on this. And see, it tells us the intersection is 1, negative 1. So if you have it, each one of them solved for y, you can easily find the intersection on your calculator. Now, so if it comes up with decimals here, that's not so easy to switch those. It's not terribly difficult, but it's not as straightforward. And I'm not going to go into much more detail than that. College algebra is where you do get into the detail of what I just said. Okay, let's take a look at this one. We want to solve this system equations by using substitution. We got y plus 5x equals negative 7. Y minus 17 is equal to 7x. And this is substitution. Now we're trying to find out what x value and y value causes this to be true. Does x equals 1 and y equals 2 cause this to be true? What exactly? Well, our first step in substitution is to solve one of the equations for one of the variables. Now it doesn't matter which one. I'm going to pick the second equation. And it doesn't matter which variable. I'll solve this for y because it's real easy. I take negative 17 over, and I get y is equal to 7x plus 17. In step 2, now plug this into the other equation. So plug this into the other equation and solve. Plug, substitute, that's where the substitution name comes from. Well, the other equation was y plus 5x is equal to negative 7. Now down here, we just said y was equal to 7x plus 17. So we're going to replace the y in this other equation with 7x plus 17. So we'll have 7x plus 17 plus 5x equals negative 7. Now you always want to plug it into the other equation. You never want to plug it into the equation you're just working with, because you always get weird results then. And now we want to solve. 7x plus 5x gives us 12x. Plus 17 equals negative 7. Take 17 over, it becomes a negative 17. This is just linear equations. Negative 7, negative 17 is negative 24. And then we want to divide both sides by 12. This is just the steps for solving a linear equation I'm going through. Get rid of parentheses, at any step combine together like terms. Get rid of parentheses, get rid of fractions, get everything with x on one side, numbers on the other side. Last step, divide both sides by a number in front of your x. And we get x is equal to negative 2. Now step 3. Plug this value into the equation. Try it again. Into the equation from step 1. So over here at step 1, we have y is equal to 7x plus 17. Now this is always the perfect one to plug it into, because it's already solved for the other variable. So it'll save you work if you always pick that one. We just said that x was equal to negative 2, so we're going to replace the x right here with negative 2. So we've got y is equal to 7 times negative 2 plus 17. Negative 14 plus 17, or y is equal to 3. And we write our answer in point form. So this would be negative 2 and 3. And let me double check everything here. Negative 14, 3. I was looking back at this one from number 1, checking it there. It's like, wait a minute, that's not checking. I was mentally checking this, plugging this in for x and plugging this in for y. So negative 2, if I put it here for the x, and 3 here, I get 3 minus 10, which is negative 7. Okay, this checks. Now, I'd also want to check it in the other one if I wasn't fairly comfortable with my work. Okay, let's look at another example of substitution. So we've got 9x minus 4y is equal to 0. And 5x plus 3y is equal to 7. Now remember our first step. Our first step is to solve one of the equations for one of the variables. I'm going to pick the first one because I think it's a little bit easier. And I'm going to solve it for x. So I'm going to take negative 4y to the right side. And it becomes a positive 4y. And then I'll divide both sides by 9. And we get x is equal to 4/9 y. Now step 2. We want to plug this into the other equation. So we've got 5x plus 3y is equal to 7. And we just said x was equal to 4/9 y. So we're going to replace the x here with 4/9 y. So we've got 5 times 4/9 y plus 3y is equal to 7. 5 times 4/9 gives us 29 y plus 3y is equal to 7. Now, if we're going through and solving this, and this is a linear equation at this point, our first step was to get rid of parentheses, which we just did. Second step would be to get rid of fractions. Now, actually, it's combined together like terms at any step, but combining 29ths and 3 isn't that easy. So let's first get rid of fractions. And we get rid of fractions always by multiplying everything by the LCM of all our denominators. If you only have one denominator, that is your LCM. So we're going to multiply everything by 9. Those 9's cancel and gives us 20y, plus 9 times 3 is 27y, and 9 times 7 is 63. Combine together like terms now, and it's real easy then. So we got 47y is equal to 63. Sometimes you'll find it beneficial when you're solving linear equations to get rid of the fractions before you combine together like terms. Now our last step is to solve, or is to divide both sides by a number in front of your y. So we're going to divide both sides by 47, and we get y is equal to 63 over 47. Step 3. Now plug this into the equation from step 1. Equations from step 1 said x is equal to 4/9 y. Now down here in step 2 we said y is equal to 63 over 47, so we're going to replace the y here with 63 over 47. So we got 4/9 times 63 over 47. Now 9 and 63 are both divisible by 9. So we got 9 divided by 9 is 1, 63 divided by 9 is 7. 4 times 7 is 28 over 47. So now our answer is 28 over 47 and 63 over 47. Let me save that, then we'll look at the next type. What's this called? Systems linear equations in 2 variables. Actually, I may not need to save this. Let's see. PDF pages. Yep. So I thought. I'm just creating a YouTube. I already created these with a WebEx video, but I'm having to go back and redo them because I didn't have the YouTube technology in place at that time. So let's go start a new page. Now this next type is elimination. Some books call this the addition method. So we got x plus y is equal to -6. And we got negative 3x minus y is equal to 20. And this, depending upon what book you look at, is either the addition or elimination method. Well, what we do is see how the x's are in the same column, y's are in the same column, and numbers are on the right side of the equals? We just combine together all the like terms. So we add these. X and negative 3x gives you negative 2x. Y minus y drops away. Negative 6 and 20 gives you 14. So we're adding them, and you see that the purpose of it is to eliminate one of your variables. We want one of them to disappear, and the y's disappeared here, so that works out really nice. And now we're left with something we can solve easily. So I'm going to go ahead and divide both sides by -2 to get the x by itself, and we get x is equal to -7. Now at this point you want to plug that value into one of your equations. It doesn't matter which one. Probably your first one looks a little easier. So we got x plus y is equal to -6. And down here we just said x is equal to -7. So we're going to replace the x here with -7. And I want to solve for y, so I take -7 over. And we get 6 plus 7, or y is equal to 13. So our answer will be -7, 13. Grab a drink here. Oops, I dropped a sign. See a mistake. Good thing I grabbed a drink. It's a negative there. There should be a negative here. Okay, let me try that again. Sorry about that. I'll blame it on having to do physical work. Let me just start over with that. We just said x was equal to -7. I didn't carry the negative down in 6 there. So I take -7 over, and it becomes a +7, and we get y is equal to 1. Which gives us -7 and 1. And that's our answer. Had a huge snow last night, so I was out there shoveling snow for 2.5 hours this morning. Used to sitting on my butt for a living, so it was a change. Let's take a look at another one. Got -5x plus 3y. Actually, I teach, so I stand a lot of the time too, but still don't do any physical work. 7x minus y is equal to 30. Okay, now if I add these together, -5x plus 7x is 2x. 3y minus y is 2y. Nothing disappears. We want something to be eliminated. We want one of the variables to go away. Well, look at the y's here. See how we have a 3y here? Think what number would have to be here for this to cancel away. Well, this would have to be a -3y instead of a -y. So we're going to multiply the second equation by 3. First equation remains as is. We got -5x plus 3y is equal to -26. 3 times 7x is 21x. 3 times -y is -3y. And 3 times 30 is 90. Now, we'll be able to add these together. -5x plus 21x is 16x. 3y minus 3y disappears. It's eliminated. -26 plus 90 is 64. Like that. Now again, your goal is that they're different signs. See how the y's were different signs? One was positive, one was negative. And they have the same number in front of the variable, like a 3 and a 3 here. Now, you don't have to eliminate the y's. We could have eliminated the x's. That's what we could have tried. But that would have been a little harder on this problem. Well, now we want to solve for x. So I'm going to divide both sides by 16. And we get x is equal to 4. Now we want to plug that into one of our equations. Second one looks a little easier to me. So I got 7x minus y is equal to 30. Both of them will give you the same answer. We just said x was equal to 4, so I'll replace the x up here with 4. 7 times 4 is 28, minus y is equal to 30. Now we want to get y by itself, so I'm going to take this -y to the right side, and I'll take this 30 to the left side. Remember, when you take anything across your equals, the sign changes. So we got 28 minus 30 is equal to y, or y is equal to -2. So our answer is 4, -2. Yeah, I might have room for the next one. Yeah, let me start a new page. Time for my tablet to blow up. There we go. We got x plus 5y is equal to -5/3. And we got 3x minus 4y is equal to -2. Well, to begin with, when we're solving systems of equations using the elimination method, the addition method, we never want fractions. They always cause us headaches. So let's go ahead and get rid of this fraction to begin with. So I'm going to multiply everything in this first equation by 3. We're multiplying by the LCM of all our denominators. And we only have one denominator, so we multiply by 3. Well, 3 times x is 3x. 3 times 5y is 15y. 3 times -5/3 gives us -5. And the other equation remains as is. Now, as I look at this, the x's look like they'd be pretty easy to get rid of. They're both 3x. I just need one of them to be negative. It doesn't matter which one. So I'll multiply the first equation by -1. -1 times 3x is -3x. -1 times 15y gives us -15y. -1 times -5 is a +5. And the other equation remains as is. Let me double check everything here. Yep. Okay. Now I can add these together. And the negative 3x plus 3x drops away. Negative 15y, negative 4y is negative 19y. 5 minus 2 is 3. Now we want to divide both sides by negative 19. Trying to get y by itself. And we get y. Those negative 19s cancel. We get y is equal to negative 3 over 19. Now we want to plug that back into one of our equations. Doesn't matter which one. First, well, I'll pick the second one. There's no fractions there. Okay, so we just said y was equal to negative 3/19, so we're going to replace the y with negative 3/19. Now we want to solve this, and we just go through our steps for solving a linear equation. Get rid of parentheses. Negative 4 times negative 3 gives us a positive 12 over 19 equals negative 2. Get rid of fractions. Multiply everything by the LCM of all your denominators. We only have one denominator, so multiply everything by 19. Um, 57, I believe. Yeah, 57x plus 12 is equal to negative 38. Let me double check all that. 7, 2, okay. 8, 1, 2, 3. Okay. Third step. Get everything with x on one side and numbers on the other. So take 12 over. This is the steps for solving a linear equation. Take anything over the equals, sign changes, so it becomes a negative 12. Combine together like terms, combine together numbers at any step. That gives us negative 50. Yeah, negative 50. Last step is divide both sides by the number in front of your x. So we'll divide both sides by 57. And we get x is equal to negative 50 over 57. So our answer will be negative 50 57ths and negative 3/19. Now let me talk about one other type. I don't have an example of it here. It's more of the type you'd see in college algebra. But let's say I had something like this. I'm not going to actually solve this one completely down. And let's say I'm going to eliminate the y's. A very easy way to figure out what to multiply everything by. First off, the signs have to be different. Both these are negative, aren't they? So you need to have multiply one of them by a negative number. Now trying to figure out what to multiply this by, you always just choose the number on the other equation. Like this 2y, I look down here, I see a 3, so I'm going to multiply this one by negative 3. For this one, I'm sitting here on my second equation, the number up here is 2, so I'll multiply this by 2. When I do that, negative 3 times 3x gives us negative 9x. Negative 3 times negative 2y gives you a positive 6y. And negative 3 times 5 is negative 15. For our second equation here, 2 times 4x is 8x. 2 times negative 3y is negative 6y. And 2 times 6 is 12. If you always choose the other number, that's a very simplest way to figure out what to multiply everything by. It might not be the smallest number, but that'll always work. You know, this one actually might come out halfway decent. Negative 9x plus 8x is negative 1x. 6y minus 6y drops away. Negative 15 plus 12 is negative 3. Oh, what are the odds? I better go to the casino today. Usually I make them up. They don't come out nice like this. I'm going to divide both sides by the number in front of your x, which is negative 1. And I get x is equal to 3. I wonder if y comes out just as nice. Plug that back into one of my equations. Doesn't matter which one. I'll choose the first one. So we've got 3x minus 2y is equal to 5. We just said x was equal to 3. So I'll put the 3 in for the x. Minus 2y is equal to 5. So we've got 9 minus 2y is equal to 5. What was a lottery? Take 9 over. Becomes a negative 9. 5 minus 9 is negative 4. And then divide both sides by negative 2. And we get y is equal to 2. So our answer is 3, 2. That's unreal. That actually came out nice. How interesting. Anyway, that's our last problem. So let me go ahead and save this now.